until the question and answer session of today's event. At that time, you may press star 1 on your touch-tone phone if you would care to ask a question. If you need to withdraw your request, that would be star 2. But again, to ask a question, please press star 1 anytime. Today's conference is being recorded. If you have any objections, you may disconnect. One moment, please, for our call. Thank you, everyone, for standing by. Now, guests are on a listen-only mode until the question and answer session of today's event. At that time, you may press star 1 on your touch-tone phone if you would care to ask a question. Today's conference is being recorded. If you have any objections, please disconnect at this time. And now I'd like to turn it over to your host, Mr. Josh Finch. Thank you, sir. You may begin.
Thank you, and welcome to everyone, and thanks for joining us for today's media teleconference to provide a status update on the first astronaut flight test of the Boeing CST-100 Starliner to the International Space Station as a part of NASA's Commercial Crew Program. I'm Josh Finch with NASA's Office of Communications. Leadership joining us to talk about NASA's Boeing Crew Flight Test, we have Steve Stich, Manager of NASA's Commercial Crew Program, Jeff Arend, Manager, Systems Engineering and Integration Office for NASA's International Space Station Program, and Mark Nappi, Vice President and Program Manager, CST-100 Starliner. And that's for Boeing. We'll begin with opening comments from each of our speakers and then turn it over to questions. And first, we'll turn it over to Steve Stich.
Thank you, Josh, and thanks to everyone who joined today to discuss the progress toward NASA's Boeing crewed flight test. We're excited to be here and to talk a little bit about that mission today ahead of the Crew 6 activities. We don't have any big announcements, but we thought we would share the progress and what the team has been working on and what we can expect over the next month or so. We're all very excited to bring the Starliner capability online to have another crew transportation system for one of only 2 certified transportation systems and human-rated systems for the space station. So it's an exciting time for us, and I know the crew is very excited about that as well. We are taking our time and being very diligent as we work through the final preparation of the flight hardware, the flight software, the crew training, and closing out all of the certification products that we need to human rate the Starliner for flight. As you know, it's a really busy time this year at the space station. The first big activity that we have is the Crew 6 mission coming up, and that is still on track for no earlier than February the 26th launch at 2:07 a.m. Eastern Time. That vehicle has been loaded with propellant. The Dragon spacecraft has, and it'll head up to the launch pad on Saturday to go mate with the Falcon 9 rocket. And then, of course, we'll have our flight readiness review on Tuesday, the 21st of February, and we'll have an opportunity to talk to you about anything that you have questions about for the Crew 6 and Crew 5 return at that time. Getting back to the busy time frame we're looking at, after Crew 6, we have a SpaceX 27 cargo mission that's very important to us. That'll launch on March the 10th and dock a couple of days later. And then that vehicle will stay there docked to the space station to move supplies and cargo over until about the early to mid-April time frame. And so when we look at the CFT mission, just from the station manifest perspective, the window for CFT is kind of the middle of April to the end of April, and that's kind of what we're looking at. And Mark will talk a little bit more about the other work on the vehicle and how we will make the decision to target the final launch date. We're taking our time with this flight. We're stepping through it methodically, just like we did our first demonstration mission for the Dragon spacecraft, Demo 2. We had a lot of validation and certification work that was actually being worked on in this very same time frame for that flight. So I would say when I compare Starliner to Dragon, it's really no different. NASA and Boeing are working together to close out all that certification and analysis work, and really this is the final piece to say that the vehicle is ready to go fly the missions and become human rated for that mission. So that's the big activity that's ongoing right now. We're about 80%, I would say, through that work, and we have some of the final work to close out and the final analysis, and we'll continue to work through that, and then Mark will talk more about it. But the next big event with Starliner on the vehicle is loading propellant in the service module. And if you remember, we have kind of a 60-day window we want to go launch within once we load that propellant, and so we'll have a decision in early March relative to when to target loading the vehicle and then how we proceed toward launch. We will go ahead and give you another update after we get through the Crew 5 and Crew 6 handover in the March timeframe. We'll have an event like this, and we'll talk to you a little bit more about the progress. I've had a chance to talk to the crew. The crew is very excited, Butch and Sunny, about flying this mission. They'll go down to the C-3PF next week and begin to look at some of the cargo for the vehicle and how the cargo gets stowed and begin to prepare as part of the normal preparation for launch. And they are in the middle of many simulations. There was a mission dress rehearsal for launch not too long ago, and then another one from the undock to landing that had transpired. The Crew 6 astronauts are really excited, talking to Steve Bowen and his crew about having Starliner there during his increment. When I talked to them a week or so ago, I told them that I was very confident the vehicle would be there, and they're very excited about that. Before I hand over to Jeff Aaron, I just want to say I'm very proud of the NASA and Boeing team and the whole CCP family. We're working through a really busy time frame, and people are working very hard, and we'll go fly Starliner when we're ready and take it one step at a time, and I'll turn it over to Jeff Aaron.
All right, thanks, Steve. Again, welcome to everybody. Thanks for coming. From an ISS point of view, we're super excited to see Butch and Sonny show up on Starliner for their 8-day mission. Both Sonny and Butch bring a wealth of experience in their careers and will complement the crew on board station brilliantly. During their time on station, they will be busy conducting science, technology, demonstrations, outreach, and commercial activities. And it's just a big deal for us because we go from 7 crew to 9 crew, and it's just having more hands on board really helps us complete our mission. In terms of criticality, this mission is super important from a certification process for Starliner for rotational flights to and from the International Space Station. So we're really looking forward to it. So it's been a busy week on board. I think you're probably aware a couple things that have been going on. I'll briefly talk about those, but I'd like to focus today's telecon on Boeing and the upcoming CFT mission. But as you probably know, on Saturday of this week, shortly after actually the 83 Progress docked, literally about an hour and a half later, the Russian MCC folks recorded a depressurization in the unpiloted Roscosmos Progress 82P cargo ship's coolant loop, which is docked to our Zenith port, our Poisk module on station. Just a reminder that the 82P Progress showed up in October of last year, so it's been on board for about 4 months. The reason for the coolant leak is continuing to be investigated between our NASA specialists and Roscosmos counterparts. An inspection was completed earlier this week using the Canadarm2 to gather imagery of the suspected area, and the teams are evaluating that imagery. We actually just polled go this morning at the IMMT, the International Space Station Mission Management Team, to have that Progress undock later this evening, 8:26 p.m. Houston time. Following the undocking, the Expedition 68 cosmonauts will send commands to the Progress to rotate about 180 degrees so that we can get additional visual inspections and documentation of the general area where the coolant leak occurred. About one orbit later, the Progress will execute its deorbit burn and perform a controlled reentry over the Pacific Ocean. The entire NASA and Roscosmos team have continued to work together to investigate the cause of this situation, and we will continue to do so. So we'll know more in the coming days, and we have a Crew 6 post-FR telecon on Tuesday next week, and then we can discuss this further if need be. But today, again, I'd like to focus on Boeing and CFT mission. On other things going on, just kind of moving on ahead, the International Space Station is excited. The whole team's excited to support the upcoming crew mission. Crew 6 will spend approximately 6 months on station and will complete hundreds of important science investigations during their mission. The Crew 6 vehicle will conduct a typical handover with the Crew 5 vehicle following launch and dock. Beyond Crew 6, coming this spring, we're excited about the Axiom 2 launching later, and it will welcome 4 private astronauts to space station for a 10-day mission, and this will be, as it says there, our second private astronaut mission to ISS. So again, a very exciting time. So looking forward to seeing another truly international crew collaborating and completing a mission together aboard the International Space Station. Thank you very much. With that, I should hand over to Mark.
All right. Good morning, everyone, and thanks for participating in this morning's event. I'm going to recap a little bit where we came from and how we got to where we are today. I remember we flew OFT-2 in the May timeframe last year, came back from that mission with really a very successful mission, but we still had some lessons that we learned, and we had to put our plans together for certification. So we took the summer to understand all that, and about the October timeframe, we established an April target for the CFT mission based on the work that was ahead of us, the hardware issues that we had encountered, and then the engineering products that needed to be completed. So we're still planning. We've maintained that plan, I should say, and we're still targeting that mid-April to late April time frame. So I think that's a real credit to the NASA and the Boeing team that, we got together, we put together a pretty good plan, and we're still executing to it. Now we look at basically 5 different areas to judge our progress and measure ourselves, and we put them on a schedule and we call them swim lanes. So I kind of refer to them as 5 different swim lanes. The first 2 are the hardware that it takes to fly the vehicle, and that's the service module and the crew module. And I'll talk a little bit about where we stand with that. The third area is the flight software and getting that to the right revision and incorporating all of the lessons learned from previous experiences. The fourth area is the mission operations planning and training, and then the last area is the engineering products. And we split the engineering products into 2 kind of sub areas. That's the design products, the things that Steve talked about, the verifications and the hazard reports. And then there are technical issue resolution from the previous flight IFAs and the hardware anomalies that we encountered through the processing of the vehicle. So I'll talk about each one of these in a little bit of detail and tell you where we are with respect to each one of those swim lanes. On the hardware is stacked. It's been mated. It's in what we call the hazardous processing area. We're doing final integrated testing there. As Steve mentioned, the crew will be down next week, and we'll be doing our crew interface tests. We're going to do that in 2 parts. The first part will be next week, and then after the cargo is loaded, we'll do the second part at the beginning of March. The additional step beyond that, which is a real big milestone for us, is to get the loading of propellants done. Like Steve said, we'll meet on that, and we'll determine, our line of sight of how the products are coming together and when we think our launch date is going to look, and that's also based on some of the ISS traffic. And we'll determine whether or not we want to load simulations, operational failure scenarios with the crew and other sims. All that work is, not all of it, but most of that work is all behind us. It's been very successful, and we've got a line of sight to get to the mission time frame and get through all of our reviews, and the flight software is looking really good. On the mission operations side, training, procedures, and all the crew activities are ongoing. They're all on plan, and of course those will continue throughout the next several weeks as just normal L-minus date kind of activities. On the engineering products is really our critical path, as Steve talked. The design products, we're in the final phases of reviews with NASA. So at this point, we have a lot of the products, or most of the products, if not all the products, are turned over to NASA, and we're in what we'll call a review cycle where they'll have questions for us, and we'll go back and forth and make sure that we're answering all their questions, and if there's something that we're missing, we'll make sure we add those back to the packages. So that's an iterative process that will happen over the next several weeks. But it's important to remember that this is, like Steve said, the final stage. We've done our designs, we've tested this hardware. The analysis is all done. So now this is the kind of, let's wrap it all up in a bow and make sure that we did what we said we were going to do, and we have all the artifacts to prove it. And that's what we're going through at this time. So Steve and I are watching this real closely, and we'll track our readiness as we go forward. On the technical side, with the technical issues, all of our IFAs have closure dates. We're working through those. They have resolution paths. There's a couple of areas where we have maybe 2 paths, and we're deciding with NASA which one we want to choose. But we have dates for all of these to close and get discussed, and they fit with our current plans. So all these swim lanes are coming together. This all leads to us being able to get together and decide, when our exact launch date is going to be, and like Steve said, that's going to be at the beginning of March timeframe. while we've been doing all this work, the crew office and Sonny and Butch have been personally involved and engaged in our technical discussions, obviously our training events, and some of our testing. So, we have stayed very close together. They feel we've had a good conversations with them. I think they feel very comfortable with our hardware and our processes going forward. So we're looking forward to continuing those simulations and those training events and that dialogue until we get to launch day. At the same time, we've been working toward our PCM-1 mission. So we take those same 5 swim lanes and we meet on them every week to make sure that we're making the progress that we need in order to be ready for that crew rotation in the winter of 24. We're working some new parachute designs to improve the vehicle. There's crew module battery mitigation steps that we're doing for longer duration missions to improve our performance there. So those are just some of the areas that we're working on for PCM that we already know we want to put in place. We're also incorporating a dual port capability so that we can dock on the International Space Station at both docking ports, and that's on plan, and that's a big change from CFT. It's going to require, or is requiring, some flight software, GNC, and some mission ops changes, and we've got a good plan, and we're marching down that schedule to be ready for PCM. So we're excited about the CFT mission. We have some incremental decision points like we've talked about ahead of us based on the ISS availability and the work that we have going forward. So we'll continue down that path, and like Steve said, we're going to take it very slowly and make sure that we address everything that needs to be addressed. So it's back over to you, Josh.
Thank you, Mark, and to all of our opening comments. We'll now turn it over to the question and answer portion. As a reminder, to get into the question queue, please press *1 on your phone. And our first question today will be from Joey Roulette at Reuters.
Hey, thanks, Josh. Question for, I guess, anyone who can answer. With all the stuff that you guys have to review before flight, and with the complications now going on with Progress and the investigation with Russia's space agency, I'm just kind of curious how you can still expect a launch date sometime in the month after next month in April. If you could kind of go into that, that'd be great. Thanks.
Yeah, Joey, why don't I'll start and then and I'll see if Mark has anything to add. What we're in the middle of doing right now is the first thing I'll talk about is the complexity of the manifest. Right now, the Crew 5 vehicle Dragon is docked at the forward port, and so with a successful launch of Crew 6 and then a handover, we would undock Crew 5 around March 5th, and then that clears that port for the cargo mission. That cargo mission would dock around the 12th or so, and then undock around the 11th. And so there's a swim lane that we're going to watch very carefully relative to the traffic, right? Because the CFT vehicle, just like for Demo 2, can only dock to the forward port. And so we'll have to watch weather delays and things like that to see where we end up relative to having a window to go launch CFT. And so we'll follow that very closely. We're working hand in hand with the ISS program relative to the Soyuz operations and the Soyuz launch. And then relative to the CERT products, we have our team, as Mark said, working together to go review those final sets of products. And we have most of them in hand, and we're working through those. And some of them we've had early drafts, and some of them we have had independent analysis on. And I think, I'll give one example of a CERT product, and just so you can characterize, kind of see what is involved. Like, we have a whole set of analyses for aborts, right? We did one pad abort test to sort of anchor the analysis, and that was at the White Sands Missile Range back in November of 2019. We now take the data from that test, the data from all the testing of the thrusters and the GNC system, and we go do an analysis of all the abort modes across Starliner, and then we go run an independent analysis on the NASA side and go close that out. So that's one example of the kind of work we're doing here toward the end of April or end of February and then into March. And so we'll just have to see how each one of those goes, and then we'll have a sense, I think, in a few weeks of where that is, and then we can make a decision relative to should we load propellant and then what launch date's achievable. So.
And our next question will be Eric Berger at Ars Technica.
Hi, thanks for doing this, and I'm going to request or respect Jeff's request to keep the call focused on Starliner, but it is disappointing that 6 days after the Soyuz MS-21 issue, we haven't really had a substantial response from NASA or been able to talk to anyone about the issues related to that. On the Starliner mission, is there going to be any demonstration of Starliner's reboost capabilities for ISS that could become a valuable asset with this vehicle? And I'm just wondering, is this strictly a test of the vehicle, getting crew to and from the station, or are you building in, additional objectives into the mission? Thank you.
Yeah, I'll take that one, see if Mark has anything to add. Great question. The mission, the crewed flight test, is really a demonstration of the ability to take crew and cargo to the space station, dock successfully. We'll have some checkouts while we're docked of things like, we have a requirement for what we call safe haven. So if the crew needs to get in Starliner, the space station crew needs to get in Starliner for a period of time, we use Starliner's consumables to keep the crew safe in that time frame where they would have to. So we'll test that out. We'll test some of the habitability while we're docked to the space station. Obviously, docked audio communications and things like that, but we really don't have any kind of reboost capability planned or a test of the reboost capability at all of Starliner. So.
I have nothing else to add to that, Steve. You covered it.
And our next question is from Jeff Faust at Space News.
Good morning. Is the question probably either for Steve or Mark, is the 60-day time frame between fueling Starliner and launch, is that a mitigation to prevent corrosion to valves that was seen earlier, or is that some other requirement for the vehicle? Thanks.
I can jump in, Steve, if you'd like to add. It is as a result of the problem that we had with the valve sticking. We are much more confident today with the mitigation that we've put in place with the purge systems and the sealing of the connectors so that we don't get that kind of moisture intrusion into the valve. But we still have that 60-day guideline, I guess I'll call it, and I've asked our engineering to go back and look at that to make sure that we're comfortable with that in case we had to go longer.
And I don't have anything to add.
And our next question will be from Marcia Dunn at the Associated Press.
Yes, hi. Thanks. For Steve or Jeff, now that there have been 2 leaking Russian spacecraft, I'm wondering whether the Starliner will carry extra seats to potentially bring back station crew in an emergency. Same question goes for the SpaceX Crew Dragon that it's about to launch. Will it carry up extra seats to play it safe? Thanks.
Yeah, Marcia, you were pretty soft, but let me make sure I understood the question. I think the question was, would Starliner carry extra seats, and then would we have any extra seats on the Crew 6 Dragon? And I would say right now there's no plans to add any additional seats to Starliner. It's really a test flight, just like the Demo 2 test flight. We flew 2 crew members on that flight. Doug Hurley and Bob Benkin were doing the same thing. Again, it's a test flight testing the capability. And then with the Dragon that we are configured to launch, we have the 4 seats nominally, and that's all we have. We have the contingency capability that we talked about a little bit, available for that Dragon as well, but that we didn't. We just don't have the ability to add extra seats at this time.
Yeah, and I don't have anything to add to that.
Our next question will be from Chris Gephardt at NASA Spaceflight.
Yeah, thank you. This is for Steve and Mark. I'm wondering if you aren't off the ground by the end of the April window, sort of how does that overall sequence with ULA's operations and the ISS in terms of when your next opportunity might be? And in terms of Starliner, would that mean having to take it back to the C3PF to have its propellant resurfaced or anything like that if you do miss the April window? Thank you.
I can talk a little bit. We've been in really close dialogue with ULA. They have an important milestone that they'd like to achieve as well in the same time frame, which adds to the complexity of our ISS traffic, and that is their testing and eventual launch of their Vulcan vehicle. So we've been in very close contact with them to make sure that as we go through this decision process, they're engaged and we're balancing, the needs between what we need and what they need. So right now, we still feel that mid-April to late April time slot is good for us. It balances with the ULA priorities. If we do move into May, we probably at the beginning of May, we're still okay. If we start slipping past that, then we'll have to have some pretty good discussions with ULA on who goes first. As far as going back to the C3PF, I think we'd need a really large slip in order for that to happen. So, we'll just address that if it happens. With Steve, if you have anything else to add.
No, I think you addressed the complexity of the ULA manifest really well, and I would say, just looking at the space station and commercial crew manifest, the priorities are obviously to get this crewed rotation completed, where we launch Crew 6 and dock Crew 6 and then return Crew 5. The next priority is to execute this cargo mission to resupply the space station and have some experiments for the onboard crew to execute. And then following that, the next priority is really, and I've had a lot of conversations with Joel Montalbano, the station program managers, to go fly the CFT crew flight demonstration. So we would make that window available. Should there be some delays or on either side, should we move in out of April into the May timeframe, we would have a window at ISS to go fly.
And our next question will be from Stephen Clark at Spaceflight Now.
Thanks, Josh. I think Steve actually just addressed my question on priorities over the spring time frame, but if I could, a question for Mark Nappi. Can you go through some of the top IFAs that you're still trying to close out from OFT2, just a status update on some of those big items?
Yeah, there's really only one big item that we have not closed out, and it's planned on being heard at the end of this month, beginning of March, and that is the OMAC failure that we had with the OMACs. We had a rationale. Remember, now we don't get the service module back, so we put together a very extensive fault tree to make sure that we went through every possible scenario, every possible fault that could have caused what we saw in flight. And since we don't get the hardware back, we have to go to the most probable. And when we got down close to closing that fault tree, we recognized with NASA that we wanted to do a little bit of additional testing. So we ran that testing in February. We've gotten that result back, and we are working with NASA to make sure that we both agree that box in the fault tree can be closed. We'll bring that back to a board here in the beginning of March and make those decisions. But that's really the only significant one that we have left. We have a number of very small ones that they all have solutions. It's really just a matter of getting them to the board and getting them closed.
And I would echo what Mark said, and we talked, I think we had sort of 6 that we sort of highlighted before when we talked, and 5 of those 6 are closed. And the one that's a little more problematic is the one that Mark talked about with the OMAC thrusters, because, again, we don't get that service module back. And so, as he said, we had to do a little bit more testing to convince ourselves that we had the failure mode right, and we should work through that here in the March timeframe and get that one behind us. One of the ones that we did close out that we're already sort of seeing the fruits of is, we had the coolant loop freeze up in the radiator, and, Mark and his team have worked several modifications to the vehicle to improve the system, and also some improvement on the loading of that fluid, which is called Galden, which is underway as the vehicle's in the hazardous processing area to get it ready for the integrated testing. And so that there's a drying system that dries out that coolant, and then some improvements to make sure that we don't have that same problem. And so it's sort of evidence to me of us working together as a team, making improvements to the vehicle. There's numerous improvements to the flight software as well on some of the other IFAs that we saw in flight, and we've made those and tested those in the hardware software simulated lab that we call ASIL, and those have checked out well.
And our next question is from Irene Klotz at Aviation Week.
Thanks very much. For Jeff, the departure of the Progress 82, that's not changed at all. That had always been scheduled for today. And is there any possibility that the coolant leak is going to make that spacecraft not controllable? And then for Mark, I think I just heard you say that you're targeting the post-certification mission 1 for winter of 24. Is that, I presume that's dependent on a launch of the orbital, of the crew flight test in April, and that's you need about 6-7 months. Is that what you're basically planning on between the 2 flights?
So I guess I'll take the first part of that. So you are correct, Irene. The departure for the Progress has been on the books. At least I went back and looked at my notes since about December 30th, and so that has been the date. So the coolant leak has to do with cooling the avionics in the vehicle. We've done some assessments. Our Russian colleagues have done assessments of how long they can operate that vehicle without cooling, and we're well within limits. So we think all of the avionics will operate as planned, and there has been no impact to the propulsion system at all. So we're very confident that the control of the vehicle will be nominal.
As far as the second part of that question, there are some dependencies on CFT. But most of the work that has to be done is not dependent on CFT. The vehicle, the service module is being built right now. The crew module is a separate crew module, so it's in refurbishment. So those 2 have a plan to be ready for next beginning of 24. Flight software, we understand what needs to be done there with the full port capability, and then we have a number of things that we want to put into our flight software for PCM. That is all in work, and we understand that. What might pop out of CFT could be some learning that takes place on CFT that we want to add a few things, but we've put a placeholder in our software update process to absorb those. So flight software is in good shape. Mission operations is pretty template-type stuff, so, again, not dependent on CFT. The certification process is what has a few dependencies. We want some data off of the CFT mission in order to conduct our certification process, and we intend to get that done before the end of the year. So specifically to answer your question, there's a great deal of things that are very independent of CFT, and CFT can move a little bit more to the right, and we'd still be able to support the mission in the first rotation of 2024.
Thank you.
And our next question is from Richard Trudeau at the Orlando Sentinel.
Hi. Yes, thanks for taking my question. Regarding the future, the 6 contracted Starliner missions, it said you were targeting winter of 24 for the first rotational mission. Does that mean you're basically set for the second mission of each calendar year? Is that sort of the plan? And is there you're out of Atlas rockets after that point for rides. Is there, I think previously you said you were looking at contingencies to potentially use Vulcan. Any progress on that? Thanks.
Okay, so we are planning for 1 flight a year. Currently, we're getting ready to be available to NASA in that first rotation, and then we're planning 1 flight a year after that. And of course, NASA needs us more often than that. We are posturing to be ready to go more frequently. We are also looking at post PCM6 or post those 6 flights when we run out of Atlases. What is the next launch vehicle we want to go to, and what other changes do we want to make in order to support the market that we see growing with low Earth orbit? So we have been in discussions with other launch vehicle providers. We're working with Steve with those discussions to make sure we're in lockstep with NASA and not just the launch vehicle integration for the new launch vehicle, but also for some of the changes that we want to make on our vehicle. So that is a very active project that we're working on, and we intend to be ready when we are done with PCM6 to move on to the next, I guess, the next stage of life for Starliner.
I think Mark said it really well. I mean, when we talk about sort of rotation slots, there's the early slot, which is the one we're about to have the Crew 6, Crew 5 handover rotation for this year. And so Mark's talking about that same time frame next year as the first PCM 1 flight, Starliner 1, which we're excited about as well. And we have been working with Mark on long-term plans beyond PCM 6 once the last Atlas has been flown out.
And our next question is from Micah Maidenberg at the Wall Street Journal.
Hey there, Steve and Jeff. At the ASAP panel meeting last week, there was a discussion of a different perception of risk between the commercial crew office and the ISS office about Starliner-related risks. Could you each talk about what that debate or disagreement is about? I'm wondering if it covers the OMAC thrusters that were discussed earlier. Thanks.
Let me try to take that one. Yeah, the ASAP's comments relative to different levels of risk. First of all, we in commercial crew and ISS program have 2 different risk systems, and I think sometimes we don't explain it very clearly why. So if I step back and look at our vehicles and the risk for launching crews and docking to the space station and then undocking and re-entering, a lot of our risks are really in that phases of launch and landing, right? I mean, the parachute system is a relatively high-risk system, as you might imagine, when you start to separate, in Starliner's case, a forward heat shield, deploy 2 drogue parachutes, then have 3 pilot chutes pull out the mains, and that all has to sequence very carefully relative to the landing event. Then the heat shield drops off and the airbags deploy, and so quite a bit of risk relative to that kind of operation with pyrotechnics, parachutes, propulsion systems, and so forth. So when I look at my risks for our vehicles, I mean, some of those kind of things will be to the top: separation systems, propulsion systems, parachutes, landing airbags, and those sorts of things. ISS, when the vehicle arrives, other than the time frame when it's approaching ISS and docking, largely the vehicle is fairly quiescent, and so there's not the level of risk is different. And so, you know, one of the risks that we've been talking a little bit about is the battery system on Starliner and what the risk of that is. And we would rank it one way in our system, and ISS would see it as a bit of a higher risk relative to the kinds of things that they're worried about. Like, for example, on ISS, the highest risks are kind of micrometeoroid impacts. Same really for our vehicles as well. And then after that, the batteries would raise to kind of a higher level of risk. But for the Commercial Crew Program and for Mark, we would have higher risks like the pyrotechnic separation systems, the parachute systems, the propulsion systems, the abort systems. Those sorts of things would be higher risk in our. So that's what ASAP was talking about. And we'll have to circle back with them and try to explain this a little bit better. And hopefully what I gave as an explanation was a little bit try to explain exactly what the differences are.
Yeah, I guess the only thing I'd add, first of all, I totally agree with what Steve just said. We work lockstep with the CCP office, and their requirement set, and it's very comparable to our requirement set. The way we certify a vehicle to come and go is very comparable to the way they do it. We've analyzed them coming and going. We've analyzed them being on station. We've worked the procedures. We've updated. We have OCADs. We have all kinds of things, all kinds of products in place. But from our perspective, I would treat both of the crewed vehicles we're talking about, U.S. crewed vehicles, as equal from a risk balance trade point of view, and we're very excited to see them show up. I'll say that again because that's kind of what it comes down to.
And our next question will be from Manuel Mazzanti from Exploration Especial.
Hi, thank you so much. Would you mind describing what kind of cargo it's on board the capsule, and if it's mainly provisions or science or any particular hardware? And what kind of cargo as well are you planning to bring back with taking advantage of this first crew flight test? Thank you.
I guess I'll attempt to take a look at that or add to that. I would say it's a combination of all of those things. We have a little bit more capacity on this vehicle since we're only flying 2 crew, and maybe Mark can help me a little bit there. One of the things we try to get back on a regular basis is NORS tanks, and I can't remember if we're bringing one back on this particular flight, but it's a fairly large item. It's one of our high-pressure tanks that we use to get oxygen and nitrogen to ISS. And but I'd probably have to take a note on that one and get back to you with a better answer, I think.
And I don't have a super good list right now in front of me of what the cargo is. I'm sure we're taking some supplies to ISS and some science, and then there's the normal kinds of things that the Starliner crew needs on their trip from the launch pad to the space station. Food, water, and various clothing and supplies like that. So, but I don't have the details.
And I'm in the same boat. We were, now just getting ready to pack all the cargo bags, and we have those lists in our engineering, so we can certainly get that and get it out to y'all.
As a reminder, if you'd like to ask a question, please press *1 on your phone to enter the queue. And our next question will be from David Curley at Discovery.
Thanks, Josh. A question for Mark. Steve mentioned a couple of the changes you mentioned in your opening remarks that you learned about some hardware changes. Can you give us a couple more specifics? And on the parachutes, what exactly are you doing with the chute rebuild? Thank you.
Okay. So as we went through the flow with both building the service module and refurbishing the crew module, we do a great deal of testing. And during that testing, sometimes we get black boxes or the hardware doesn't quite work like we want it to, maybe a sticky valve. And so we discovered a few of those things as we were going through the processing of the vehicle, and we addressed them. We replaced one valve that had a sticky poppet in it, and there were just a number of those little things that had to be addressed along the way. As far as the big things that we wanted to go do, and they really are related to PCM, is with the parachute mod, and then we mentioned we wanted to increase the reliability of our batteries by putting some barriers in between them. The engineering team's off working those options right now, and we expect to have that design complete, and so we can go ahead and incorporate that for the PCM mission. And then on the parachutes, we really are just looking at, and Steve could probably talk in a lot more detail on this, but we're looking at really beefing up the sturdiness of the lines that we use on our main parachutes. We've got material coming in here next month, and we'll start building 3 new chutes or 4 new chutes that will be an enhancement over the chutes that we currently fly. These will give us more capability on these chutes for more robust, I should say, capability on these chutes for hardier conditions that we can land in. And we expect to have those chutes ready for us by the end of the summer. Looking like we're going to do some kind of drop test to verify that system works like it's supposed to, and then again be ready for the February timeframe.
And I'll just add one thing on the chutes. This is a relatively minor modification. It's not a large redesign, and this is on the main canopies, the 3 main canopies that's used to slow the Starliner down for its final descent and landing on the airbag system. It's really to strengthen the joint, like Mark said, as there's 80 suspension lines that kind of hold attached to the parachute and kind of come down and attach to something called a riser. And there's just one what's called a joint that basically attaches that suspension line to the main canopy, and it's going to get strengthened a little bit, and we'll test it to make sure it's good to go fly.
Is this different than what SpaceX did with their changes to their chutes?
Yeah, I should address that. Thank you for that question. For SpaceX, we had, I would say, a major redesign of the parachute system, and this is going back a number of years between the demonstration 1 flight, which was the uncrewed flight, and the crewed flight test, or the demo 2 flight, which was the crewed flight test. We did a major redesign to that parachute system to strengthen many areas of the canopy and to change the way that it inflated. And it was a major redesign that required a number of tests to get that design iterated upon, and then a number of final drop tests of that configuration. This is by no means that kind of redesign. This is really not changing the performance of the system at all. It's really just, think about it as, in a mechanical system, it'd be like putting a stronger bolt in a mechanical system. In this textile system, it's just making this one joint a little stronger. And we just want to make sure with one parachute drop test that we haven't changed any of the other properties, but the team feels really confident about it.
Thank you. I think I would add, Steve, that these are the kind of changes that we will probably see through the life of the program. Both Steve and I's experience on Space Shuttle, that we were making modifications throughout the life of the program as we learned more about our systems, as we got better materials, et cetera. These changes were just smart to go do, and we'll revisit these every mission, and then we'll plan them in for the proper flight.
And our next question is from Chris Gephardt at NASA Space Flight.
I'm wondering too on this. Could you also walk me through a little bit of the software here? I know you said there's some minor changes to the software, so I'm just curious. How many end-to-end tests were done with the software that's going to fly on CFT, and are those runs complete, or do you still have some more software testing ahead of you?
Yeah, I wouldn't begin to guess a number. There's developing software is a very iterative process, as most of you know. So we go through that iterative process to develop the software. It's all tested a number of times, and then we go into failure mode testing with the team and the mission ops team, with our flight software team and the crew, and we intentionally fail a number of different systems to see how everything reacts. We also do just normal end-to-end mission type of training to where we exercise the crew, the team, and the software so that we can validate that everything's working like it's supposed to. And so it serves as, checking the software, and it serves as a practice session for the team. Again, I'm not going to guess on how many times that this software gets tested, but it is very extensive. And what we're getting to the point where we've gotten through all these tests. We're looking at the data. We may want to run one or two more failure scenarios to get even more comfortable, and the software teams between Boeing and NASA are looking at that data now to see if we want to run those tests, and we've made a hole so that we can go do it. But that's about all that's left with the flight software for CFT. Now, PCM, what we do is we go through the number of PRs or problem reports that we've documented, the changes that we want to make with this dual port, and then we'll look at how many things that the mission ops team do today do we want to retire and incorporate into our software. That process is all taking place now so that we can determine what goes in that last revision of software that will be happening in the middle of the summer.
And our next question is from Michael Sheets at CNBC.
Hi, everyone. This question's for Mark. On the Aerojet Rocketdyne valves that had the corrosion issue 2 years ago, I'm curious, we talked a little bit last year about both short-term mitigations as well as long-term redesigns that were under consideration. What's the latest on what the short-term mitigations were that have given you confidence to move forward with this flight test, as well as any considerations and discussions on, or even just work already on redesigning the valves for the rest of the future 6 crew missions? Thanks.
Yes. So on the short-term mitigation, of course, we implemented that short-term mitigation for OFD2. It worked really nicely. We're doing an enhanced version of that for CFT. And that, what I mean by enhanced is that we're just, instead of putting the enclosures in after the fact, after the vehicle's built, we're putting these enclosures in as the vehicle's getting built. So it just makes it even more robust to make sure that the environment around those valves doesn't contain any moisture. So we're pretty confident with that process. It's all complete, it's all behind us, and we've been testing it, and it's working great. As far as the long-term solution, we have a redesign. We have been working with the supplier. Those design reviews are in process. They're actually building hardware, and we would like to get that targeted into the earliest mission possible. It's questionable whether we can get it there for PCM1. Definitely we'll get it there for PCM2. We're not going to give up on one, and if we don't get it in on one, we'll use that short-term mitigation one more time.
And our final question for today will be Joe Roulette at Reuters.
Thanks. Quick question for Mark, or maybe Steve wants to answer. What are smart initiators? Thanks.
Steve, you want?
I could take a crack at that. Let's see how to describe this. Most pyrotechnic systems are relatively simple in that you send a command from the flight computer to that pyrotechnic system, and then there's something called a NASA standard initiator, and then it initiates that pyrotechnic burn to do that separation function, whether it be a bolt or a SEP system. Boeing has implemented something called a smart initiator, which has a delay time in it. So it can stagger, when it gets the command, it can stagger when that pyrotechnic device fires. And they do that because when they go to separate the crew module from the service module, they need a kind of a staggered timeline, and that command gets sent across the umbilical, then the umbilical gets cut, and then the service module needs to separate on its own. And so that smart initiator really is just a way to have what I would call a delay time in for that pyrotechnic separation. So hopefully I answered your question. So.
Yep, thanks.
Thank you to our speakers and for the media on the line today. That's going to wrap things up for us here. We'll have more to come on this important flight test, so follow us online and on social media. And you can learn more about this mission at nasa.gov/commercial crew. Have a good day. Thank you.